Welcome back to the Gloomwood inventory tutorial. This is going to be the fourth part. In this part, we're going to be going over the inventory actor components. And this is kind of the backbone of everything. It is not going to be visual, but we're going to be setting up all the logic needed so that in the next part, we can just open our suitcase and have our inventory display itself immediately. So let's get into it. Go into the Gloomwood folder, go into Blueprints, and right-click Blueprint class, and select the actor components. We'll call this AC underscore inventory. And for now, let's just do something very simple. We're just going to open it up, and on BeginPlay, we're going to press print, and we're going to add it to our character. That's all we're going to do. So we're going to go into our content. We're going to go into third person character, blueprints, third person character. And we added our AC interact. We're now just going to do the same thing with our AC underscore inventory. And we're done. Now, we are going to keep it open. Oh, actually, no, we don't need to keep it open. We can just close it. So close it. We're done. Let's play. And we should get hello. We do. So the AC inventory is attached correctly. Let's move on to the next step. So the next step I want to do is in the inventory, we're going to have a lot of functions. So we're going to go through them one by one. But before we do that, I want to make sure that we have all the different little pieces that we're going to need from our macro library ready so that we don't have to go back and forth. So we're going to start with that. So back into our content browser, back into content, Gloomwood. In structure, I believe we put it. Yeah, look for the macro library or ML grid that we created. And so last time we made, or in the last few parts, we made the for each loop or for each slot. We made the toGrid, the GetMaxValues. We're going to start with, we're making a duplicate of this, of GetMaxValues. We're going to duplicate it and we're going to call it GetMinValues because we're going to need to do the opposite here. Just like before, but this time a bit different. So we're going to remove this. We're going to get min this time. So min of float array. And we're looking for this again, but this time we just want to pass it straight out. We don't want to subtract one. When we use max values, we're specifically looking for the length of the shape, like the max length on X and Y you can have. And to get that, you need +1 because the coordinates are 0, 1, and let's say 0, 1 and 0, 2. That's a length of 2, but it would only return 2 if we just got the max value here. But in the case of minimum, we're never really going to be looking for a negative value. We're never going to be looking for the length based on the minimum. The whole point of the minimum is to get the coordinates. So xspan isn't correct here. We're going to change the name. But the reason for that is because in some cases, when we're going to start rotating this shape, we'll get a negative value. And if we have a negative value, we want to know how far it is negative so we can shift it back in the right direction. So that's mainly what we use GetMinValues for. So we're going to use only the min, but not a plus or a minus. So we're just going to copy this, attach it to the Y, pass this to truncate as well, and we're just going to rename this here. So this will just be, we'll call this min X, that way it's clear, and here min Y. And we'll actually rename this instead to get max values to get shape span. Go ahead and add a new macro, and this new macro is going to be called rotate 2D, and this is where kind of the basis of all the rotation starts from. So as long as you're following exactly with how I explained how I made my 3D meshes with the whole pivot point and how it should be looked at and how the shapes should be made relative to it, then these values will work. Because what we're going to do is we are going to give it an input or two inputs. One is going to be the rotation, which is the float, so rotation. And the second one is going to be the 2D vector. This is going to be the coordinates. And we're simply going to manually tell it, okay, if we rotate it by 90, this should be the result you get. So that, because the reason I do it this way is because there is a function that says rotate this one, get rotated 2D. But the issue with this one is that it always does it relative to 0, 0. And the problem with that is if we have it here and we click on this coordinate is 0, 0. And so if we were to rotate this, normally you would rotate, let's say we rotate it 90 degrees in this direction. then this should no longer be 0, 0, because it would be here if you rotate it, right? But with the specific function here, getRotated2D, this would never change. It would always be 0, 0. Whereas this one, for instance, right here, would go here. And that doesn't exactly work. And it needs to be adjusted in a bit more complicated manner, at least from my testing. And maybe I did it wrong. Maybe someone in the comments can actually show me a better way to do it. That would actually be brilliant if you know. But so for now, I used a custom method just to make sure it works with my needs. So replace this with coordinates. And now we're going to go one by one with a little reroute. We're going to say right here, is it double equal to 90? We'll start with that, or we'll just actually do it this way instead. We'll start with 90 and just go through them one by one. Give it a bit of space, it needs a bit of space here. Same thing at the top, reroutes. Actually, this one will go a bit further and we'll put another one here, which will bring down, we will break, and we want to invert them. So we want to say make 2D, and we're going to connect the y to the x and the x to the y. Then we want to multiply it, and we want to multiply it by -1 on the x and 1 on the y. And so then we simply want to say select, and the index or the condition will be if it's 90. So if it is equal to 90, we want to use this formula here. If it isn't, we're just going to use the default coordinates passed in, because this will be considered 0 degrees. And if it's 0 degrees, we don't want to rotate it. So let's move this down so it kind of lines up. So add another reroute here, because we're going to do this a few times. Another one here. And then we're going to say double equal. Drag it to the bottom one. We'll say -90 this time. And once again, we're going to use a different trick where this time we break it again and we say make 2D. And we just invert it this time. And, oh, sorry, we don't just invert it. We do the same trick as we did here, but instead of minus on the x, we're going to say minus on the y. So multiply 1 and -1. So make sure these are exactly the same as me, otherwise you will end up with an issue. And this should also be a part of selects. I think this is gone. Yeah, there we go. So once again, select. Now, if this is double equal to -90, we use the new one we just calculated. Otherwise, we use the previous value we had. So just line this up. And finally, we have one last one before the output. And we're just going to reroute all of this again one last time. There we go. And say if it is double equal to 180. We want to select. And top one is always going to be false once we plug in the Boolean. And this time we don't want to do any breaking or inverting. We just want to say times -1 -1. Because this is just going to be the opposite. It's going to be diagonal from itself, so negative on both sides. There we go, and now we just plug this into our output, and this will do it for our rotate 2D. So I'm just going to go through it again and make sure you get this exactly. So for the first one, if it's 90, you want to invert it first, x to y and y to x. Then you want to multiply x by -1 and y by 1, so that it stays the same. And this is for 90. Make sure you plug it into the true. If it is not 90, so for the first one here, it just means it's 0. So we pass in the basic coordinates that come in. On the other hand, if it is equal to -90, on true, we're going to invert it, and we're going to multiply it by 1 on the x, but -1 on the y. So the opposite of what we did for 90. This obviously goes into true. False will get the other select. And finally, the last one, which is if it is equal to 180, we just want to multiply the input coordinates by -1 on the x and the y, and pass it into true, and the other previous selections into the false, and the final one into the outputs. And now we can move on to the more important one, which is going to do this all in one go, because we don't actually use rotate 2D on its own, but we do use it in a separate thing, a separate macro. So we're going to call this rotate. Oh, that's not right. Rotate 2D array. There we go. And for this, we want an input of type executable, an output of type executable. And just to make it so that we don't have to read these, we're just going to put a space bar on both of them, or 2 on the second so it doesn't appear. Then we want to have an input of type 2D vector. And we want to turn it into an array because we're going to pass through our shape, and then it's going to pass out our rotated shape. So right here, we're going to say shape. And we're going to need a second input of type float, and it's going to be a single, so make sure you reset it from the array. And this is going to be our rotation. We'll call it new rotation. And finally, the output, which is just going to be our 2D vector array, and we'll call this rotated shape. This should be what it looks like at the end, and we're just going to move it because we need a decent amount of space here. So the first thing we want to do is we're going to do a for each loop. So by pressing F, I made that appear, by the way, if you don't know that trick. We're going to make a for each loop, and we're just going to rotate them with the function we just made. So we're going to say rotate 2D, and we're looking specifically for the macro, not the get rotated. And it should look like this. For the rotation, new rotation, just plug it in. I just added a few reroutes so it looks a bit nicer. With this, we are going to pass this into an array. So we're going to say add here, and specifically add array. So plug this in to the loop body, and here we're going to need to now call local wildcard array. Or sorry, no, just local wildcard loop. Local wildcard. Let's just move this here because we're going to need to do some extra stuff here. So add a few reroutes here so it's nice and tidy, or as tidy as it can be in a macro. And there we go. So this isn't all we need to do, because right here, as I mentioned before, this is just rotating them. It doesn't care whether it's a negative value or not, but we need them all to be positive. So we're going to now tell this array to shift relative to, well, our minimum values, because this new array, so we're going to go here, we're going to look for GetMinValues. And the shape is going to be, well, the exact same one we have here, because it's going to be set up here, and after it is done, we can then get the new values from it. Now, we're going to need another for each loop, so press F and left click, add it here, and obviously the one we're going to use is this. So I'm actually going to lower these a bit, even if it means that one looks a bit weird. There we go. And this is going to go in here, and we're going to need another reroute a bit further down the line. Go. And what we're going to do is we're going to use the set array element to modify the original array, or the array we're using here. Sorry, not the original one. The original one we never want to touch. We're going to use this local array and modify to what we need. And so first we'll start by getting our array index and just plugging this in right here. And now we're going to modify this. So we're going to reroute and convert these to float. So look for to float, and we're looking for the first one here, conversion. Copy paste it, plug in the Y as well. And here from the array element, we need to get a 2D vector. So to do that, because it doesn't know, we need to do this. We need to connect it to something so it understands what we're talking about. Then we're going to say minus, and we're going to subtract the values here from the total that we have. There you go. Now I'm actually going to move these up instead. I think this lines up perfectly. It does. So we'll just do it that way instead. And we're just going to pass this into here, and that will give us the result we need. Now, the last thing we need to do is we need to return this. So we're simply going to plug this in on the completed. So once both loops are done, we can pass out our rotated array, which is still this one from the beginning, because we've just modified it as we've gone. And so this should do it for rotating any item that we have. And this is the last one we need in our actual macro library. So we can now close this. Let's start with our variables. That's what we're going to do first. We'll start with our variables. First variable, we're going to call it occupied slots. And this is going to be the only one that is going to be a map. So we're looking for 2D vector, and we're going to need to convert this into a map. So in the top right, in our details panel, go down to map, and we want it to be a Boolean. And I'm going to call this, and I'm going to say this right now, be very careful when using this. And the reason I say that is because if we use this, and we're going to use this, if we say find, this is what happens. You have two Booleans, so you need to be very careful which one you use. And if you're ever in doubt, you can always hover them and it will tell you which one is which. The bottom one is if an item is found. The top one is the value that is found based on the key that is input here. If you're ever in doubt, you can also just disconnect this, and you can see that the bottom one stays a Boolean because it's based on the found as well. So just be very careful with this, because depending on what we're looking at, these two may be identical, but they definitely won't always be. Now that the warning's out of the way, next step is inventory. And this is going to be a array. So right click it to turn it back into an array. And we're looking for st inventory, which is, as the name suggests, it's going to have all the items that are in the inventory. And it doesn't matter which location they're in, that will be handled inside the item itself. Next is our pre-population. Because even though we do have a pre-population system on the items, if you want to have this inventory, let's say on another character, even if they don't have the actual briefcase that we're going to have, you can still give them this AC component so they have an inventory. They just won't be able to interact with it like the player does, but it could very well be used for trading. It's also an option. And if that's the case and you want to have them, or even the player, have items beforehand, this is what that's for. It's so that we can say, well, this and this item are already in the inventory, just like we did for this, but in the inventory. So for pre-populate, we want to use our I think st underscore pre-populate here, and it needs to be an array as well. I'm going to put these three in a category for storage, as that's exactly what they're used for. So there we go. Next up is a few kind of helper variables. First one is going to be called item rotation priority. And this is going to be a float, simple as can be, and what it's going to be used for is to say what rotation we want. And so that means, in our case, it's always going to be blocked between -90, so you can fill these in so that you don't actually go over them, -90 and 180. So this is pretty much the rotations you can always have. -90 going to the left, and 180 all the way around to upside down. This value is also going to be the one that we use to say, because as you probably noticed in our pre-populate, we don't have anything related to the rotation, or we don't have coordinates. And the reason we don't have that is because we're just going to say, if we pre-populate, we just fill it one by one, add it to the inventory based on this item rotation. And it will be the same when you pick up an item if let's say you pick up an item on the floor instead of dragging it in, it'll be added automatically to the inventory based on this rotation. So next, oh sorry, I also forgot, we want to make sure this is instance editable so that you can actually see it when it's on a different character. A different player can have their own different rotation priority. Next is the size. So we're going to have columns and total slots. And so these are going to be integers, both of them, and they're also going to be exposed on spawn, not exposed on spawn, instance editable. So just click the eye icon, compile, and we're going to set default values of, I think columns will say 10, and for total slots we will say 35, so that we don't have a completely square system. I also forgot we need to make pre-populate visible as well. There we go. And that'll do it for now. We do have an extra variable left, which is just a reference to our actual briefcase, but for now we're going to leave that on the side. So let's make this into a category as well. We'll call it setup. That's specifically what it is for, these three variables. Now let's talk about the functions. So I'm going to go through them one by one, and then we'll start building them as we go. So first one, try add item. Just as the name suggests, we're going to use this to try and add an item. We're going to, based on the input of the type structure, or the structure of the inventory structure type, we're going to say, can this item be added? And it's going to return whether the item was added and how much is remaining on the actual source block, just in case we want to, for instance, delete it or try again. So this needs to have an input of type st inventory and 2 outputs, one of type boolean, one of type integer. The input is going to be item. The output is going to be destroy item and remaining, we'll call it. And so once again, if there is no remaining, then we destroy the item. That's the simple purpose of these 2 outputs. Next, add quantity to slot. This one is used in pair with the old one and has 2 inputs. The input is what are we adding? So it's going to be the st inventory. And the second one is going to be how much are we adding to it? So this is going to be input. And this is going to be inventory. Quantity in. And the reason it works like this is because we have our inventory here. So we simply tell it, well, this is the array element that we're going to be adding to. So we just say, well, this is the quantity that's going to go in. And one thing to do is we want to make sure our quantity in is as a pass by reference. That way, if we make any changes to it in here, which we will do, then it will replicate on the outside. Next one is going to be our item interact. And this is specifically designed to go with the function that we made last time for when you pick up an item. That's what it's for. So that means an input is going to take a actor. This, and for the output, we're going to put a boolean to say, can we destroy the item? So right here, destroy, we'll call it can destroy item. And we'll call this input. So this one doesn't need to be passed by reference. Just be a reference, a normal reference is just fine. And if, for instance, this item is completely consumed based on try add item, then we can say destroy item, and within the actual interaction system, we can say, oh, well, that item's gone. We can get rid of it. And on to the next one. So we're just going to put these into a group, add item. Just like that. Now, next, we're going to have some conditional stuff. We're going to have does contain item. And this is going to pass in the object. So we're looking specifically for an object here. This one right here. And just as we had before, or as we have in our st inventory, it's a soft object reference that we want. So this is going to be called in. And it's going to return 2 things. It's going to return did it find it, a boolean. So return value. Or call it found. Was found probably is better. And for the last one, we want to know which structure in the inventory was it. So st inventory. So this will be called the item. Plural. It is an array because it is possible that there are multiple times this item. So if they do exist multiple times, we want to know that so we can actually go through and add it to each individual one if it is needed. So just like this. Next, we're going to make another one, which we'll call can add to slot. This is going to have 2 inputs. It's going to have 2 outputs. This is used to check if the slot physically exists within the occupied slots. So we need to know the 2D vector. So just a basic 2D vector here and single. And this is going to be the coordinates. So where we are trying to place it. Then we're going to look at the shape. So this is going to be, again, a 2D vector. And we're going to check, does this shape, these coordinates, does this shape, so this local shape, can it be placed at these coordinates? And so we're going to say shape. And for the output, we're going to say, was it possible? Does it fit? So does fit. And the second one is rotation used, because as I mentioned previously, with our item rotation priority, we will say that we, for instance, want to use 0, but it might not work as 0. So this is going to check whether it works with 0, and if it doesn't, it's going to try with 90, it's going to try with minus 90, it's going to try with 180. And if it can find nothing, it can't fit at all. And if it can fit, well, then it will tell you where and at what rotation. Because it's going to try the coordinates. We're going to try the coordinates one by one, but this one will check one specific coordinate. Each rotation, does it work? Yes, no. And which one succeeded. Next, we're going to do another one, and this is going to be called Are Slots Available? And this one is a bit different than this. And it's going to be used joint with it, because this one is going to just pretty much call Are slots available in each rotation. But this also allows us to check when we're moving our items, is this a place that we can actually use by checking if the slots are available. So it's going to have two inputs, both 2D vector arrays. So 2D vector array, so both of them, there we go. First one is going to be an input pick. This is going to be the actual shape coming in. But the second one, and I don't believe in my whole project I used it, but I set it up in case, because sometimes based on how you set it up, in my case, how we're going to use it, let me just explain. When we pick up an item, when we start dragging it, that item is going to be removed from the inventory. And that can sometimes lead to issues, like if the game crashes or something goes wrong, it'll say the item never existed. In some very rare scenarios that may happen. So this here is specifically designed to say, oh, well, this is your old item. It used to be here. Let's pass in an ignore. So these coordinates can be ignored in the check. And if it places, it places. Even if the item used to be there, it still works. And it's going to return whether those slots are available. So a Boolean, single, and just is available. These ones, so as I mentioned, are kind of conditions. So we're going to put them in a category called conditions. Or actually, I prefer to call them checks, because that's what they do. They check if stuff is available. Next, we're going to have add item to inventory. And this is different from this, because this one is actually going to test whether it's possible. This one is not going to ask any questions and say, okay, add it to the inventory. This is going to take in an input, and it's going to take in, this takes in two things. Okay, so this one here has two inputs. First one is st inventory. We don't actually need the second one here. I'm just going to stick with this. And we're then going to make a duplicate of it, and this one will be called remove item from inventory. And just like the previous one, does the same thing. It directly removes without asking any questions. So these ones are going to be in a category we'll call direct. Next, we want another one, and this one's simple. It doesn't need any inputs or outputs. It's going to be called initialize the occupied slots. And we're going to leave it just like this. Then we're going to need three more here. First, it's going to be get relevant coordinates. It's going to, based on the input, or three of them, sorry, and one output, it is going to get the specific coordinates in the inventory based on the coordinates input, the shape input, and the rotation. So it's pretty much just going to kind of package everything in one go and just return everything we might need to know about the slots that we're going to be accessing. So the input is going to be the first one is going to be a 2D vector. Second one is also going to be a 2D vector, but in an array. And the third one is going to be a float for the rotation. So first one is coordinates, and second one is shape. And the output is going to be a 2D vector array. And this one will be just called relevant coordinates, we'll call it. I'll just put the return value, more like, because that's the name of the function. Then we're going to need another one. And this other one is going to be, I duplicate it, no, won't duplicate. Press plus, and we're going to call this get relevant items. And this is going to go in some cases where we need to know the specific items, and they are used specifically when we are talking about merging. If, for instance, one item is dropped on another one, it's nice to know that it's occupied by getting the relevant coordinates, but it doesn't tell us which items it is. So it will indeed take in the relative coordinates. So this is the coordinates, not the shape. These are the coordinates that the shape occupies, yes, but it's not the shape itself. But it also needs to take in which object we're looking for. So soft reference here, it needs to be a single, and we'll call this object. Object, because what we're actually using this function for, and it is for the case I mentioned, is this is specifically used to check whether we can stack one object on top of another. So it means we know where we're dropping, what item we are trying to drop onto, and if it is identical, we'll let it know by passing out the index of this inventory here. And the reason we're doing it with an index instead of passing out this is because we're going to have a second index that is almost a copy of this, of our inventory, but it will be referencing actor components instead, the actual A items that have spawned in the box. So because they're mirrored, because they're identical, because this one will be used to populate the other one, we need the index, and with the index we can access both of them without any issue. So this is going to be an integer, and it's going to be an array because there may be multiple relevant items. This will be our return value. Okay, and we have one last one to do, and that is a little function called getCompleteData. And we're going to put these three in a category called getters. So these three right here, and this one will be in a category for initialize. There we go. Or setup. Actually, we already have one for setup. Let's just put it there. So complete data is the last one we just need to do, and complete data takes in an input of type object, this, and as a single array, and it outputs an st inventory. So in our case, for instance, we have, where is it? We have our add item inventory. If ever, for instance, you would have an object and not the actual structure that you need, well, we will use this function to do specifically that. So this is going to be our output, and this is just going to be an input because there's nothing particular about these two. This can be pure as well while we're at it. Okay, that does it for all the functions, or at least the setup of all of them. Now let's get into it. We'll go through them one by one, and we're going to start with initialized occupied slots. So open that one up. This one is the simplest one we probably have because we simply want to create or populate our occupied slots. So what does that mean? We want to go through here and we want to say add. And by default, these are all going to be empty. There's going to be nothing in them. So what do we do? Well, we have a function called a macro called for each slot, which allows us to go specifically through our total slots, our columns, and create the slots for them. So just plug it in here, and we're pretty much done. This will set up our array, or our map, sorry. Now there's only one issue. This works absolutely fine, but we do have a pre-populate data. So we're going to go through it by doing a for each loop right here. And we need to use this to try and add an item. But the problem is this isn't the right type to call try add item because it needs something else. So we're going to do that conversion. And that conversion isn't too difficult, but I'm just going to give us a bit of space so that we can nicely see it. So we're going to break this, and inside of it we have our data asset and we have our quantity. And what we're going to do is we're going to say get complete data, because get complete data, as I mentioned, uses an object, and specifically that means a U object. And so as long as it is something that is made in Unreal pretty much, it'll work. It can handle this. And obviously the way we're going to get it to work is our blueprint interface. So if it doesn't have blueprint interface, it doesn't work. But in our case, our items do. We've already set that up. So what we need to do with this is we could pass it directly here, but that isn't going to work. And the reason that isn't going to work is because we don't have quantity. So we're going to say set members right here. We're going to plug this into the body and this into here, and the output will go right there. And then we're going to say quantity, which is going to go in right here. Now, little issue is in our item, we had something set up so that the quantity could never be 0 or could never be too high or too low. The problem is here we don't have that because it's an array. So we need to handle that a bit differently by dragging this, giving us a bit of space. We can actually hide this one, and we're going to have to say clamp. And we're going to have to clamp this value as we pass it in based on this break max quantity. So max is here, and we want it to be a minimum of 1 because there should always be at least 1 in a stack. So hide, and we're good here. And we can just add this a bit around so it looks a bit nicer. There we go. Just give it a bit more space. There we go. So this is what it should look like. And then we just pass it into our try add item, and we don't care about the remaining or destroy item because this is done in the pre-populate, so nothing technically exists anyway. And that'll do it for our initialize. Let's move on to the next one, the try add item. So try add item, we're going to split, or we're going to move this, and we're going to do things little by little. So first we're going to promote this to a local variable, which we will call L_item info. And we're going to start with a sequence here. Not that, a sequence like this. And with our item info, drag it in here, control to make it a getter. We're going to break it. And the first thing we're going to do is we're going to say, does it contain an item? And the reason we're doing this is because the first thing you usually want to do when you have an inventory is, can we stack it? Can it be added to something that already exists? So we're going to do that first. And we just need our quantity. The rest isn't important. So we're going to add some reroutes, and we're going to hide disconnected. So this is what it should look like here. Now, the first thing we want to check is it found? And if it is, we can do something more. If it's found, we can go through this list and see if we can add to those already existing items. And to do that, we already have a function called add quantity to slot, which is specifically designed to handle this. It just needs to know the quantity that needs to come in. So this right here. And remember, I'm going to say it again. I specifically said, make sure this quantity in is passed by reference. And for those who don't know what that does, is it means any changes within here will apply to this value right here within this. And so that means that in here, let's say we add to the quantity, we add 3. And let's say there's 5 quantity coming in. Then that means this now is 2. And we can check it on the next loop. It will be 2, and then it will go down as it keeps going. And after this, we can actually say, okay, you've just removed 3 from it. Is this inferior or equal to 0? Because if it is, we want to stop. We don't have any more items to actually add, so we're just going to stop. And in that case, we will return that we can destroy the item because there's nothing left. Now, this is the first scenario. It's possible that this happens, it caps, and then there's some left. So if there's leftover, we're going to handle the rest, or it may not even be found in the first place. If that is the case, we need to look at adding it to the inventory. So we're going to say for each slot. For each slot is, once again, our columns for here, our total slots for the total, and I think I did that correctly in Initialize. Let me just double check. Total at the top. Yep. Okay, we're good. And we go back to our try item. So now we're going to go through these, and we're going to call again can add to slot, which will allow us, based on our coordinates here, to see whether the item can be added. So the shape is going to be our local item info break, and we're just going to pass in the shape like this, and we can hide the stuff. Now, I'm just going to line this up here. There we go. And we're just going to move this a bit because we need a bit of extra stuff here to pass through. If the item was found, or does fit, sorry, then we need to know where and how to change it. So we're going to go into here with our S item in our L item info. We're going to set members. We're going to set our members. And the members we're specifically going to set is our coordinates and our rotation. And so the coordinates are very simple. We get it from the slot. the slot is the coordinates we will use. So we'll just reroute all the way around, bring this a little bit closer. And for the rotation, we're going to do it based on where we found that it fitted. So just another reroute so it looks nice and tidy. And now that we know this, we've checked that it fits. We know that it fits. We have the new coordinates, we have the new location, the new rotation. And now we're just going to say add item to inventory. And we're going to do it directly because we know it works. We know the value is, and the information is correct. And now we're going to say return true, because we know for a fact, or at least it should always be this way, if you have an item that is added to an empty slot, it should always go to its cap, because an item can only be added at its maximum, so it can never occupy more than one slot. So that means if it reaches here, it should always be true. There's nothing else we need to check. And finally, to finish, we just call return here. We return false. And we say that the remaining is simply this, which is our item info, broken, and its quantity. And the reason for this is because, once again, if we ever reach this point and it is valid, it will always return empty. But if it's done anything here, the value will have changed, so the quantity is always going to be the remainder. That'll do it for our try add items. Let's close it and move to add quantity to slot. Once again, we're going to save this because we actually need to keep these two separate now. So we're going to promote this and we're going to call this L underscore new structure. And the reason for this is because before we make any changes, we need to at some point find the item within the inventory so that we can then replace it with the new value. The first thing we want to do is we want to get this. We're going to break it. And we want to check whether our quantity plus the quantity that actually comes in, so get quantity in, if this plus this clamped to the max quantity, so right here we're going to get our max quantity. Let's just line these up and we can collapse this and add a reroute or two just so it looks a bit nicer. Actually, we're just going to line this up first. There we go. And then this to this. If this is true, or we don't actually care if this is true, sorry. We're just going to promote this to a variable. And this is going to be the L new quantity. So this is going to be the new value that the input or the value we passed in. If we have an input of an item, let's say that has 5 on it. It can have up to 10. And we pass in 6. We're trying to add 6 to it. Then in this case, it's going to say, well, we're going to cap at 10. We have our new quantity, which is equal to 10 on this new item. And now we just need to be able to say to this quantity that it is equal now to 1 because we used 5 of them. So to do that, we need to get our quantity in, so specifically quantity in here, and we're going to say assign. We're going to say set by ref. And this looks familiar because it's exactly like it is in the actual macros. And this allows us to change this variable. And it can be done for anything. It doesn't have to specifically do for an int, but in our case, it's an integer here. So we'll give it a bit of space because it's going to need a bit. We're going to get our new structure here. So then we're going to break. We're going to get our quantity. We're going to get our quantity in here. And we're going to say this plus the initial quantity, pretty much, or the quantity we have now, minus the max quantity. So let's close this. Is going to be equal to our new value. So this is going to get passed in here. I'm just going to walk through it in a second. Let me just line this up here. There we go. So what this means is we have, let's say, we have our 6 input here. 6 plus the quantity initial, which is 5, so it is now 11, minus the max, which is 10, will be equal to 1. And that's how much will be left in this. And so the reason we have to do it this way is because we want to make sure that we never change this before we know exactly what the values will be at the end. Because now we can actually say our structure here, set members right here, our new quantity to our new quantity. Plug this in here. There we go. And so to finish this, because this is all well and good, but this is still local, doesn't change anything, we need to then call our inventory. We need to say set array element. And the way we know which array element we're looking for is we can actually copy this, say find item, and the item we're looking for is our input, because our input hasn't changed. That's why we have a local variable here. So we can call this in the index and be sure it's right and replace it with our new structure, just like this. So make sure you never use the input here. This has to be the new structure. And the same, this doesn't really matter too much because it's just getting information. It's mainly the set. You want to make sure it's the new structure. And that does it. That'll do it for our add quantity to slot. Next is item interact, which also is going to be rather simple. The first thing we want to know about the item we're trying to interact with is, does it implement the interface? Because if it doesn't implement our BPI here, or our blueprint interface share info, doesn't matter. It's not going to be able to do anything. So we're going to put a branch right here, and we're going to return that we cannot destroy the item because it couldn't meet the condition. So we're just going to leave it as it is and do nothing. Now, on the other hand, if we do have it, or it is valid, we're going to get our input value. So get our inputs, and it's going to be here in the variables. We're going to say get complete data. And with complete data, we're going to call try add item. And if that succeeds, so with a simple branch here, if it succeeds, we can say true, we can destroy the item. Now, on the other hand, if it is false, meaning right here, we need to do something else. So we need to return, obviously, but the issue is right now, we have a remaining. We've just changed the item. But because we don't want to have a hard reference to every type of item, we want to use it with our data asset, with our blueprint interface, we need something to happen here because this just isn't going to work. We're not going to be able to change this structure because this structure doesn't exist on our input. So the way we do that is we are going to need another blueprint interface. Well, not another blueprint interface, but another function. So we need to go to our Gloomwood, our structure, and we're going to go ahead and open our BPI share info. What we're going to do is we're going to get all of these and we're going to put them in a function or a category we'll call get data. And we're just going to move all these in very quickly. And we are going to make a brand new function for a brand new category, which we're going to call set coordinates. And I'm just going to make all three of them because there's just three of them. It's very quick. And this is going to be in set data. And that's the whole point of this. So this is going to have an input instead of an output. And it's going to be a 2D vector. And this is going to be new coordinates. And we're going to have a duplicate. And it's going to be called set quantity. And it's going to be an integer instead. So new quantity. And one last one, which is going to be set rotation, which is going to be the same thing, but a float, and it's going to be new rotation. And so now we have a means to actually change the values of the item directly. Now, obviously, this isn't going to work if we don't set it up, but for now, we have our function and we can use it. So we can say our input here, we can say set quantity, and now it knows how much is left. And we can tell it doesn't need to be destroyed because there's some quantity left. So let's just line that up nicely, and there we go. That'll do it for item interact. Let's move on to the next one, does contain item. So move this bit to the side. Actually, not to the side, this needs to go to the bottom because it's going to have a for each loop. So for each loop through all our items, so our inventory, drag it in. We are going to break it right here. We're going to check for two things. One, are these different quantities? And the reason we check that is because if it's full, it doesn't matter. The item is useless. You can't do anything with it. So, and then we get our object reference and we're going to say, are you double equal to our input? So check for these conditions, hide the pins that we're not using. And there we go. So we'll add a branch. There we go. And so if we found it, we're going to reroute. We're going to add this to an array. So call add. I'm looking for array on true, and we're going to promote this to a variable here. So L underscore local items, we'll call it. And then with this, we're done. We're just going to tell it to be, once it's finished, completed, we will pass out our local items. And we're going to say if local items is not empty, then that means we have items. So something was found. There we go. So that does it for does contain items. Let's go to can add to slot. There we go. This one is going to start off by checking information. So we want to know our relevant coordinates. And this, for information, should be a pure. So convert that to a pure. And it's also true for our slots available. It should also be pure. And so with this, we're going to call our slots available. And we're going to check it. And what we're going to check it against is our coordinates here input, our shape input, and the rotation we're going to use is our item priority. And so what this means is once we get into this element with a branch, we're first going to check, is the default value okay? Can we immediately start with this? Is it valid? And if it is, we're simply going to return that it did fit and that it fit with the item rotation priority. Now, if this doesn't work, we're going to do a for loop. And this for loop is simply going to be 3, because we're doing it 3 times. Simple as that. And what we do is we have a switch, not a switch, a sequence, sorry, like this, and a switch. So I wasn't going to add a switch, I just forgot. So just reroute this index above, add a switch, and we're going to switch between 1 or 0, 1, 2, and 3. And for each switch, we're going to create a float. So in our local variables here, we're going to call this test angle. And it's going to be a float, and it's going to start off at 0 on 0. On 1, it's going to be 90. So this. On 2, it's going to be 180. And on 3, it's going to be minus 90. And so this is the order we're going to test in. And we're going to do one extra thing is we're going to have a branch here. Just like this. And it's going to check whether our test angle is equal to our item priority. Because if it is, we've already tested it. So there's no point in testing it again. So we check that this is different. Because if it was already... If it is the item priority, we've already tested it. So there's no point in actually looking at it again. We already know it's not going to work. And on completed, we're going to return false. Because that means it doesn't fit at these coordinates because we've just tested them all right here. So copy this exactly as it is. We can get rid of that, sorry. Copy this, paste it here, and replace item rotation priority by right-clicking and replace it with the test angle. And make sure you do, otherwise we'll be testing the same angle every time. Branch on true and check whether this works. If it does, we can return positive this time. We can say return true and the test angle that we just did, like this. So this should be the end result. This is what it should look like. And it should be true here and false here. Next one are slots available. We're going to start with a for each loop through our input pin. And the input pin is going to look first whether these coordinates are contained within the array that is our ignore. That way, if it is, we don't care about what happens here. So if it is contained within here, we don't care. It doesn't matter. So we want to specifically look for false here. So just add these reroutes, even though they're not necessary, just add them so that you're sure that you use false and not true. And here's where we're going to need to look if we can actually find it within our occupied slots. So remember what I mentioned earlier. So find, and we're going to use both of them. We're going to look for both of them because both conditions are necessary. Because if the bottom one being if an item was found, meaning if the coordinates actually exist, not if they're occupied or not, if they exist. Because for instance, if your item is all the way on the right of the screen or of the inventory, then it's going to have to check outside of the inventory. It will check those coordinates. So we need to know, do they exist? And this will tell us that they do not. And if they do not, we stop everything. We return here that it doesn't exist, that the item cannot be placed here because the coordinates don't exist. Now, on the other hand, if they do exist, we still need to check if they're not occupied. So we're going to call another branch here. And this time, if it's true, you want to return false as well, because that means that it is occupied and we cannot use them. And so that means if we go through the whole loop without any issues, without ever getting outside or an occupied slot, then we can return that it is available. We can compile, close our slots available, and next is add item to inventory. Okay, we'll start with promoting this to a variable, which we'll call LData. Well, not like that. That's not how you write. That's not how it should be written. Data. There we go. And the first thing we're going to do with this data is we are going to rotate the information, because I mentioned this, I believe, in the previous part, but the whole way I made this system is I made it so that you never have to change this. The shape never gets rotated directly. It is always getting rotated here by using the rotate 2D array specifically. We really don't want to actually have to handle this any other way than this. And I just realized I sorted these differently, and because it's going to be a pain in the ass for me, I'm going to invert these two. It doesn't change anything at all. It's just going to be so that here it looks a bit nicer when we collapse this. There we go. So this is going to get a new output, and this output doesn't change the shape, so we need to save it because we're going to need to use it and modify it. So we're going to call this L_rotated shape. There we go. And with it, we're going to go for each loop through it like this. And we're going to get our L data, and we're going to get its coordinates, because even if this rotates the shape, it doesn't do anything for the coordinates. So we're going to break it right here. Yeah, actually, we can do this a bit differently because I missed something that I have a function that's a lot easier. Use get relevant coordinates here. Pass in the information that we need. So we're going to break this. We're going to pass it through, and we're actually going to invert this as well, our shape and our rotation. There we go, and shape, and then we can say hide connected, plug this in, and we're going to promote this to our relevant shape for it. And we actually don't need our data, so we'll just do it this way directly. There we go. And this should give us the same result in a much more simpler form. So remove the rotated, remove the data. And with this, we're going to go through it for each loop, and we are going to get our occupied slots, say that it is now occupying that location, so add. And so for those who aren't aware, if you add to a map to a value that, or a key that already exists, it just replaces it. It doesn't add a new value like in an array or a set, it just simply replaces it. So in this case, we're replacing it by true because there is now an item there. And so now we just need to add the item to our inventory. So get inventory, call add, and just pass in our new item. So new item. All completed. There we go. And we can actually just copy this right here and go into remove from item, paste it, and pretty much it's going to be almost the exact same with a few minor differences. So just turn this into a local variable again by right clicking. And this is going to become false because now it is no longer occupied. And instead, we're going to say remove from the inventory. And so remove this, and we can remove to our get relevant. So this is the one that we were using just there. So hopefully this explains what we did. It's going to be very similar to what we were doing, but I ended up stopping. So we're going to use our coordinates. We're going to say rotate 2D, not that one, from the shape, rotate 2D, pass in the rotation, plug this in here, and promote this to a variable. This will be called our L_rotated shape. This, plug it in, and we're going to do a for each loop, just like this. And like before, how we were starting to get our item, we were going to do it for the coordinates, so that we could add the actual coordinates to the rotated shape. And so we're going to say plus. We're going to get those coordinates specifically. So coordinates. And we're going to get our rotated shape. We're going to say set array elements. And we're going to update the amount of elements as we go through them. So there we go. And we're then going to return the rotated shape because it has been updated and it has everything it needs to know. So that does it for this. We have get relevant items and then we'll be done. No, sorry, we need get complete data as well. We'll move this a bit. I believe we need a bit of space here. Actually, this doesn't go here. It goes at the bottom. First thing we're going to do is we're going to make a... We're actually going to go and call a function called add items. Make sure it's plural because we want to use the set. And we're going to get our coordinates here, which will turn this into a 2D vector type. I'm then going to promote this to a variable we will call L input chords. Chords. Double O. That is not how you write it. Coordinates, or that's how I'll cut it, make it short. So the reason we're doing this is because we're going to need to check sets. And the reason we're using sets is because it's much easier, because with this I can say difference, I can use union, and this allows us to check specifically if there's any match between these two things. And if there is, we can use it. So we're going to go through our inventory, because this time we need to check specifically the whole inventory for anything that matches. So we need to check all of them. So right here, we're going to promote this to a variable, which we will call L underscore current item. Then we're going to get our index, which we're going to promote as well. So local variable L underscore current index. And we're going to make a duplicate of it. And this is going to be our L underscore return array. And this is going to be an integer array. So right click to turn it into an array. And we'll leave it for now. Now we're going to need another input set here. So duplicate this and call it current chords. Or you know what, we'll call it item sets, so that it has a very different name to the input chords. We're going to start by clearing it here. And what this input set is used for, this one, is to get the coordinates of this right here. And the way we do that is we are going to get our current item, the normal one, so this one right here. And we're going to call break. And with this, we're going to call our get relevant coordinates. And with relevant coordinates, we now know the necessary coordinates. And so just like before, we have an array, and we're going to convert it into a set by calling add items. And so now we have two sets, one that is based on the item that we just input, so the coordinates here, and one that's based on the item that we're currently looking at in our for each loop of the inventory. And so if these two overlap in coordinates and they also overlap in the type of the item, then we have a match and we can save it. So to check that, we need to look if this and our first one, our input chords, have an intersection. And what this will do is it will check if at any point or any one of these coordinates within this or this are equal to one another. If it happens once, then it will return it into the next set. And so if this is not empty, that means there's some overlap. So if that happens with a branch here, then we can say our return array gets to be added, or our current index gets to be added to our return array on true. This is just the first test. We actually need some other stuff. I completely forgot about that. So the next test is, okay, we know the coordinates overlap. Let's now test if our current item, so if we break this, is its object type or object reference the same to our object that we actually input. So this hide conditions and just line it all up. And so if this is also true, then we want to check whether our item here has enough space to be considered a part of this. So we just want to know our quantity, our max quantity. If these two are different, then that means that we have enough space. So untrue, if the quantity and max quantity are not the same, that means there's enough space to add to this item. So in that case, we return the index. So at the end of our loop here, we just pass out this, our return array. And now for our final one, which is going to be the annoying one, because this is going to be a bit boring, is this, is our get complete data. And our get complete data is extremely simple. We just need a lot of space to do it. So just drag this all the way to the side. This much should do. And we're going to say make our output. And this is as simple as it comes. We disconnect this. We get our input, which is called input. So right click, get input. And there's going to be a lot of them because of the specific term we use, which is stupid. Or that I use, which is stupid. And we're going to look for our get coordinates. And this time we use the message because we don't know what type this is. It's just an object. So we just use our BPI share. So plug this in. Now we're just going to repeat this process for every one of the lines. So copy this. We're looking for rotation now. Get rotation. And reroute. Plug it in. And I'm just going to repeat this for pretty much every single one. So I'm going to speed through it and I will see you once it is done. There we go. So that does it for all our functions. And now the inventory is complete. It is done. But just to test if this is working, let's do a little bit here. So first, on our event graph, we're going to start by calling our Initialize occupied slots. And what this will do is it will create this. It will populate our inventory with the pre-populated data if it exists. And one other thing we're going to do is we're just going to make sure our item priority is set to something valid. That is always a multiple of 90. So we're just going to put a reroute here, right click, and we're going to collapse the nodes. And we're going to say ensure valid rotation. And then we're going to control double click to open it up. And inside of it, we're not going to do anything too complicated. We're just going to say if the values are not equal to the 0, the 90, the minus 90, and the 180, we're just going to set it to 0. So we're going to say select here our item rotation. If our item rotation is different from either 0, 90, $180 or minus 90, so right here, minus 90. If it's any of these, so all, sorry, got this wrong. This shouldn't be equal. It shouldn't be different. It should be equal. That was a bit stupid on my part. So copy it 4 times. If it is equal to 0, 90, 180, or minus 90. It's equal to any of these, that means we can use this. If it's not, we want to set it to 0. There we go. So double click anywhere to close that and join back up here. Now for now, this is technically done. And the way we can check if this is just working, even though it's very simple, we're going to go and open our third person character. So look for it in here, blueprints. And if we look at AC inventory, we can change some information. Our pre-populate should be empty. Actually, we don't want it to have anything in there for now. And by default, we'll leave everything as it is. We want columns 10, total slots 35, and rotation 0, 0. 0 is fine. And so now we're going to say play. And if we eject by pressing F8 and click on our character, look at the details, go down to AC inventory, we can't see anything because I forgot to do something. We want to make sure this is visible and this is visible, just so we can test for now. So let's redo that. F8. And if we look at the player here, we look at AC inventory, we can see there's 35 occupied slots, and that is correct, or 35 because we have 35 total slots. And if we look at the coordinates 0, 0, 1, 0, 2, 0, 3, 0, and it should go all the way to 10 being 1 because it resets at the beginning, and element being 9 being the 10th column. And it should repeat this process until 20, where it then becomes 2, 19 is 9 and 1. And it should repeat this all the way to 34, where it's 4, 3. Okay, so this is working. Let's now test if we add something. So if we go into our third person and we say, okay, we want it by default to have a pre-population with, let's just say 5 here, and it's going to be an I block. Data table doesn't matter. And if we now play, we should have, if we look at our character, AC inventory, we have 1 inventory item. This doesn't matter anymore. We know this works. If we go in, 0, 0, the coordinates it was placed because it can. It put itself at rotation 0, quantity of 5, max quantity of 10. All the information we need is here. Let's close it and let's do another test. Let's change it so that it now is supposed to set itself to 90 degrees. Let's go and play. And if we do F8, click on the character, click on inventory. Once again, no problem. It's spawned and it's at 90 degrees this time. And that should do it. Let's add a second item just to see that it is actually taken into consideration that the slot is occupied. By saying in our player character, add a second item, open it up, say it's 2. Make sure it's not the same item. Make sure it's something else. So a T block and an I block. And let's compile and play. F8 to get out. Look at our AC inventory, and we have our 2 pre-populated things. Inventory now, we have 2 items, 0, 0, 90 for the I. It's the first block to come in. And if we look at the second one, it has 3. So it's at different coordinates because it realized that it could not be placed in 0, 0. And because the block is 90, I'm pretty sure it is being placed like this. So what's happened in the inventory there, just so you're aware, so you can check or visualize if it worked. We have this, and we have this. These are the 2 items that came in. This first one, we forced it and told it you have to appear at this angle, 90 degrees. And so this one tried to place itself in 0, 0, realized it wasn't possible, tried to place itself in 1, 0, 2, 0, and 3, 0. But 3, 0 doesn't work like this, but it does work like this. If we now put it at 90, it would have ended up like this. So this is how it actually placed itself in the inventory. And we can go and double check that again by looking at our character, checking its inventory, and look at the second item. It has a rotation of 0, which I believe means, actually no, sorry, I think this is wrong. How it should have appeared, because based on if we look at our T block here, yeah, so what happened is it appeared like this, at 0 degrees, and this fits just fine. So that's the situation that just happened. Now, we have one last thing we need to do before we finish this episode. It's going to be very short. We're going to go into our Gloomwood, into our blueprints, into our AC interact, and we are going to finish off what we started, which is our try pickup item. So let me just open that up. Now, try pickup item is rather simple, but we need to have something first. Because this is all well and good, but we have a little problem. We still don't know what the inventory is, because it doesn't exist, or we have no reference to it. So we need to get a reference to that. And to do that, we're going to go here. We're going to say get owner, which is once again going to give us our player character. We're going to then say get component by class. And this is going to be our AC inventory. And if it is valid, so it is valid because it's important, it might sometimes be that AC interact doesn't have an AC inventory with it. We're going to promote this to a variable. This is going to be AC underscore inventory ref. And that's all we're going to do with it. Now, in our pickup, we can actually do something with this information. We want to check first, does this exist? Because as we've done before, we set this whole thing up so that it can happen without it. So we're going to get our closest actor. We're going to promote it to a variable. And this is going to be called item to add, we'll call it. L underscore item to add. Now, one thing to note about this, it's not a perfect method. And the reason for that is because if you start your animation here, the item that you're looking to pick up may be different from the one you actually end up picking up if you move during the animation. So with this, we can then call our AC inventory because we know it exists. And we can say item interact, which is the function we made, which allows us to try and pick it up. So we're going to say item to add. And we can line this up. And if this returns true, then we need to destroy it. And so that means we need to say from our, our item to add, we need to say remove item, remove from interaction, and we plug it in here, true. And so that means we close the interaction if necessary, but otherwise we remove it from the array because it doesn't exist anymore. And then we can say destroy actor. So let's try this out. This means that we normally should be able to add it to our actual inventory. So if we go over to here and we press F, we should now have 3 items. And the reason we have 3 is because we just picked up 10 worth of I. And in our character, we already had 5. So that means it shouldn't be able to store that much. It should have 2. And we have 3 here, so it does seem to have worked. We have our first one, which is now capped at 10. And our third one here, which because our second one here is our T block, is once again an I block, but with 5. And as you can see, it's in coordinates 5, so it means it realized and spaced itself out correctly. If we now go and pick up this again, this is another 10, so let's pick it up. We should have another item because once again, we don't have this place to store it. So if we go in AC inventory, we have 4, and it seems to be working just fine. This new one has become 5, and this one here has become 9. Well, sorry, this one has become 10. So that does it for this part. I think it took a bit longer than I expected it to. Okay, a lot longer than I expected to. That's 1.5 hours, and I didn't even have to do too much debugging, so this is going to be a long episode. I hope you enjoyed. I believe this is more to what people actually came for, because it's actually the inventory itself. So I hope you actually enjoyed this part, even though it was a bit longer and a bit more tedious. I'm sorry we couldn't really do much testing, because it's very difficult to test these parts individually. I tried to do it as best I could at the end here, but if you have problems along the way, I'll make sure I made sure to do the functions one by one, so the timestamps should be easy to follow and make sure that you did get the functions correct. Anyway, hope you enjoyed. Thank you. Thanks to everybody who's been supporting me on Patreon these last few months, and I will see you guys in the next part. Goodbye.